All right, section 9.2. Still doing the inequalities, still kind of working back and forth with the different parts of it. Oh, sorry, 9.3, my bad. We get to skip over 9.2. That with 9.3, we're doing absolute values. Now, and there's two things. We've got absolute value equations and we've got absolute value inequalities. And the very first thing we're looking at in 9.3 is the equations. Okay. And there's basically two different things that we're kind of looking at. Now, they start you off with a very, very, very basic problem, and we'll get to that one in a minute. But when you're doing absolute value equations, there's basically three things you want to do. First thing is, you always want to solve it so that you can get the absolute value. Before you do anything at all, you've got to get the absolute value by itself. We'll say the absolute value notation. It's the best way of saying it. And this one, because it's an equation, doesn't matter whether you put it on the left side or the right side. If you just want to keep moving to the left-hand side because that's what we were doing on the last problem, that's fine. So once you've got the absolute value equation, the notation part by itself, this is where you're going to split this thing up into two parts. Okay, so let's just say, just to kind of give you an idea of what we're looking at. Let's just say you had a problem over here where you had absolute value of x plus 1 equals 9, something like that, just something pretty short here. In this case, we've got step 1, we've already got the absolute value by itself. It's more of the second thing we're looking at. Once you've got this absolute value by itself, then here's where you're going to split this thing into two parts. You're going to take the absolute value that's here, because absolute value is a measure of distance. And we're talking about distance, we're talking about straight line distance. You can either go forwards or backwards. We're not talking about in this particular part of it, we're not talking about any direction. We're talking about forwards and backwards, or up and down, left and right, that kind of thing. That for this part of it, you need to be 9 units away from something. Well, on a number line, you can either be 9 units to the right of it, or you can be 9 units to the left of it. And as long as you're either one of those two distances, they don't care. You just need to be 9 units away from this thing. So they say, okay, here's what we're going to do then, is that to set this thing up, we're going to split this into two parts. So this distance could be 9 units in the negative direction, or it could be that we're going 9 units in the positive direction. Yeah, so once you get the absolute value by itself, that's where you want to split the two separate parts of it, where you got one with a negative, one with a positive. Now, here's the only time that you kind of want to not do this. And before we get to step 3, here's where we'll kind of do one exception here. So the one exception where this is kind of like a 2A and a 2B kind of thing. The one exception where you won't do this is if you have absolute value of x, whatever this thing is. Doesn't matter, what it is. You got the absolute value by itself, and it's equal to a negative number. that if you have absolute value of x equal to a negative number, with distance we always want it to be positive, that you're either going one way or the other, and it's directional. It's to the right or it's to the left. If you have a negative distance, if you're moving up and down, would you tell somebody to go 5 spaces in the negative direction? Could you dig a hole negative 5 feet into the ground? Well, if you're digging a hole negative 5 feet into the ground, aren't you digging a hole up? So because you're digging a negative direction, right? So instead of digging down, now you're digging up, which you start contradicting yourself, right? You get this double negative stuff. So that's all right. Let's just keep it simple. Everything has to be in a positive direction. So if you're going to dig a hole 5 feet in the ground, you're going 5 feet into the ground. If you're going to climb a ladder, you're going to go 5 feet up and not go 5 feet down. That kind of thing. So if you have something where you got it equal to a negative number, we're going to say, all right, that's just no solution. That doesn't make any sense. So before we get too confusing and try to start digging holes in the air, let's just say, all right, we're not going to do that. This is just, no, we're not going to do that part. So if you get absolute value of x by itself and that's a negative number, just stop, you're done, it's no solution. Okay, so once you split it up into the two parts, this one wasn't a negative number. If we back up here, this one was a positive 9, so we're good. We don't have to worry about it. Once you split this thing into two parts, then the last thing you're going to do is you're going to just solve each equation. So once we're here, we're going to do x plus 1 equals negative 9. And then we're going to do x plus 1 equals positive 9. So for this one, we'll subtract 1. So x would equal negative 10. And when we solve this one, we'll do the same thing. We'll subtract 1. So x would equal 8. Okay. So when you're solving the absolute values, that's the key thing is that if we're talking about absolute value on a number line, you can either go to the left of it or you can go to the right of it. You need to be a safe distance away. If you start talking about, that we're in a rocket city, rockets explode. This would be where you want to be a safe distance away from where the rocket's going to explode. So you need to get either, so far this way or so far that way so you're not in the blast zone when this thing's going to happen. Okay, now, here's the thing with some of these. Some of the examples, that was just kind of walking through this. Some examples, they give it to you where it's almost, if that was example 1, they almost make it where it's almost too easy. Where they give you something like this, where you're going to do the absolute value of x is equal to 18. They give you the absolute value by itself. So if you start splitting this thing apart, x could be negative 18 or x could be positive 18. And that's it, you're done. Because there's nothing to add, there's nothing to subtract, there's nothing you have to do to solve it. So there you go, you got your two answers. Okay. And then from there, they get to the problems that's just a little bit longer. So here's one where you actually have to get the absolute value x by itself. So let's say you've got the absolute value of x plus 9, and that equals 16. Okay, again, the math on this part really shouldn't be all that hard. Just subtract 9 from both sides. You got absolute value of x is equal to 7. And once you've got the absolute value all by itself, again, just split it in two parts. The thing with this one is that once you do that, there's nothing else to do because the x is by itself. So once you're there, then you've got your two answers. You've got one answer at negative 7, you've got the other answer at positive 7. Okay, so say you've got an absolute value of 2x minus 3 plus 7 equals negative 4. Okay, same setup here. Got to get the absolute value here by itself, so we're going to get rid of that 7. So you've got the absolute value of 2x minus 3 equals negative 3. Okay, and there's your checkpoint. If that number is negative, if that number is negative, when you get the absolute value by itself, you stop and say, all right, no solution. Okay, and you will definitely get some of those that's going to pop up as you're working through the homework because they want to make sure that you know you've got a trick question there basically. And they'll give you the option of clicking on the no solution part when it comes down to it. Okay, here's one where they get a little bit sneaky. Maybe not too bad, but we'll see. Negative 4 times the absolute value of x equals 0. Okay, again, you got to get the absolute value by itself, so the very first thing is you go back and divide both sides by negative 4. 4's cancel out. You got absolute value of x equals, what is 0 divided by negative 4? 0. Now, that's not positive or negative, right? 0 is just kind of neutral. It's in the middle. It's independent. So, absolute value of x equals 0. Once you get here, if you split this thing into two parts, you don't have a negative 0, right? It doesn't really exist. So, if that's the case, this doesn't really make any sense. So, you just kind of go, well, that doesn't even do anything. So, for this one, you only have one answer. And for almost all, and all the other problems, if you're doing absolute values and it's equal to a number that's not negative, if it's some kind of positive number that you're looking at, you're always going to have two answers. The one exception is if you work this thing out, you get to the end, you get equal to 0, you're only going to have one answer. But 95% of the time, you're going to get two answers when you're working through these problems. And if there's anything that most people tend to miss on these problems, on the tests, is that they'll put one answer, and then they'll forget to put the second answer if you're doing a problem like we're back up here. That they'll give me this answer of 7, because you can do 7 plus 9 and get 16. They just forget that you could also have, the negative 7 that you could also throw into that problem. Okay, and then what we're going to do is 9. That was 9.3. That's all your parts of it for 9.3. We're going to go ahead and put 9.4 together because there's only two different types of examples here. So we'll go ahead and run through 9.4 because that was so short. All right, so 9.4. Basically, we got two objectives here. We're going to solve an absolute value inequality, which is, we're just going to type back into the inequalities we were doing back in section 9.1. So 9.3 was all about the absolute value equations. 9.4 is all going to be about the absolute value inequalities. Okay, now, before we get to the different types here, here's what you've got to realize. When you're going through the absolute value inequalities, just like the equations, you've got to get the absolute value by itself. Now, for this one, we're going to go ahead and go one more step on it. With the equations, it doesn't matter where it is. That's fine. But for the inequalities, you want to get the absolute value notation by itself. on the left. Because it's less than and greater than, so you want that x or that v or whatever that variable is, you want it first, so that when you've got it first, you've got your directions and everything is set and it goes from there. Okay, once you've got the absolute value notation by itself and it's on the left-hand side, here's where you've got the two possibilities. Well, let's just, hang on, let me back it up here. Best way of saying it here, we'll do it this way. What inequality sign you have determines which word that you're going to use. And if you go back to the inequalities we were doing back in 9.1, it's either an and statement or an or statement. So this one, it's all going to depend on which way you have. So we'll do it in two parts here. If you have absolute value of x less than some number, or again, you could have absolute value of x less than or equal to some number. But the key thing is that you've got a less than in there somewhere. So if you've got an absolute value of x and it's less than some number, this is going to force it to be an and statement. Okay, and when you have an and statement, you're going to sandwich it between two numbers. And those two numbers are going to be the positive number and the negative number, like we were doing with it last time. So if you have a less than, that's an and statement. And if you have an and statement, you're going to sandwich that number between, or sandwich that inequality in between two numbers. Okay, and then the B part, of course, if it's not less than, it's got to be greater than. So if you have absolute value of x greater than some number, or you have absolute value of x greater than or equal to some number. Again, the key thing is that we're talking about greater here. And to me, this is the one that's really the easier of the two to kind of key on, because when you do this one, the greater part tells you that it is greater, but it's greater. That if it's greater, it becomes a or statement. So this part of it, is a little bit easier because of how it's set up. And here's the thing with these. When you get finished with it, here's where it gets even better. If it's an or statement, when you get finished, the graph looks like ors, because you got the or statement here. It looks like ors on a board. Because it should be that you get something that's going this way, and you should have something that's going that way, and you've got this gap that's in the middle. And when you have the and statement where you got it sandwiched between two numbers, when you do the graph, should have put it back here. When you do your graph of it, it's the same way. You're going to have some number here, you're going to have some number here, and if you fill it in the middle, well, there's your sandwich with everything in the middle of it. So it looks like a sandwich when you get finished with it because you got this little chunk of it in the middle that you're going to have. So an and statement, which starts with less than. If it's less than, it's really like less than. You know, if it's than, it becomes an and statement. Then you sandwich it between the two numbers. If it's an or statement, because this is absolute value of x greater, when you get finished with it, the graph looks like oars on a boat. Okay, so that's basically your setup. And when you graph it just like you normally do with all the other graphs, and everything else kind of goes from there. But that's pretty much your two things you're going to do. The whole key thing, though, is once you get the absolute value of x by itself, everything keys on which inequality sign you have. If it's x less than, it's one way. If it's x greater, it's the other way. And it's just a matter of keying up which ones you're going to have here. Okay, so this one is just the first thing there. You're solving an absolute value inequality. This one's type 1. And with the type 1, that just means it's really short. So they're going to start you off with absolute value of x greater than 3, or greater than or equal to 3. And for one this short, they don't even ask you to solve it because there really is no solving on this one. They just ask you to graph it on a number line. Okay, and the key thing you're looking at is what's the symbol? Is it greater or is it less than? In this case, it's greater. So really it's greater because of the or statement part of it. So when you get finished with this thing, it's the absolute value of x is greater than 3. Or, you know, and then here's where you would kind of split it into two parts. That you've got the greater than 3, we're also going to have the less than 3 on this part of it. When you put in the negative 3, because you're introducing a negative into the inequality, this is where you're going to have to flip this sign and make it go less than. And that's where you get the oars on the boat look to it. Okay, so we need everything less than negative 3, so we're on a solid circle here. Going that way. Solid circle 3 going that way. And again, this part that's in the middle for this part of it, you really only have to show this part of the work. That part's kind of optional. The key thing is that you just got to recognize that it's greater. This is just kind of, if you had something more complex that we'll do on the next one, that's where we would actually kind of solve it and go through the parts of it. But they ask you to graph it, so that's your answer right there. So if it's greater, it's an or statement, and this should look like oars on a boat, that if you were to go back and, you know, fill in the bottom of it, there's the bottom of your boat, there's the oars, and, you know, put a guy or a girl in the middle here, and, you know, there they are, and there's their arms, they're freakishly long, and now they're in the boat and they're rowing, right? There you go. There you go. Yeah, I'm not an artist by any stretch of the imagination, so I'm terrible. I'm the world's worst artist. I'm an accidental artist. Sometimes I'll draw something and I get finished. I'm like, oh, look what I did. I'm like, I can't do it again, but hey, there it is. So, okay, so if it's an and statement, let's give you one of those. Sorry. So say you've got absolute value of x less than 7. So if it's less than, that means it's going to be an and statement. Now, if it's just the absolute value of the number, the first couple of problems you're going to go this one, that's all it's going to be. You're not going to have to add or subtract or move anything around. That to get this thing to work out, all you're going to do then is you're going to have this thing sandwiched between 7 and -7, and x is going to be in the middle of it. So if it's less than, that's an and statement, which means it's got to be sandwiched between the positive and negative of this number. And because of how it is with this part and everything turned around, this sign that's here actually will stay the same on both of these. So that direction will stay the same of both. And if you're wondering, well, why is it the same? I thought if we put a negative in there, we had to reverse it. Well, technically, if we split this thing up into two parts, you would have x less than 7. You would also have x would be a -7. You would take that inequality and flip it around. But if you flip this thing around and turn it around, you've got that. And then you just kind of put this down on top of it. So really you've got that -7 is between, or x is between 7 and -7. So it's one of those things where they kind of tie it all together. So you don't have to worry about this part over here. It's more of just realizing that, okay, if you do this, just sandwich it between the positive and negative of those numbers. And this one, you technically flip the sign because you put the number first, which means when you put the x in, it's kind of out of order to start with. So that would be your answer if they ask you to solve it. Okay, now they'll probably ask you just a graph in this case. We've got 7 and -7. And when you get finished, open circle, and it's just everything in the middle. Okay, and as far as the top 1 problems go, that's it. It's either an and statement or it's an or statement, so you'll get 3 or 4 problems on that one, and all they're trying to get you to do is just to realize that before you do anything else with more complicated problems, once you've got the absolute value of x by itself, everything depends on what's that sign. And once you know what the sign is, that's going to tell you whether it's an and statement or whether it's going to be an or statement. And that's the whole thing that you're trying to key on with these when you get through the parts of it. Okay, and for this part, they skip part or top 2 and they go straight to top 3. The good thing is that it doesn't mean it's 3 times as hard. It just means it's got a couple extra steps to it. So, and they're really not as bad. You know, you'd think top 3 sounds like, and then we're at the end of the bottom of the page here. Let me go to a new page. It seems like it would be really bad, but they're really not all that different than the top 1 examples. Okay, let's go with absolute value of u plus 2, and let's go with that greater than or equal to 4. Okay, now the absolute value is already by itself. It's on the left-hand side, so it's good to go. The only thing you have to look at is, what sign do we have? And sometimes it helps to say it out loud. That is definitely greater, right? If it's greater, that means it has to be an or statement. So when you get finished, it's going to look like oars on a boat, that you should have a gap in the middle and you should have something out on both sides of it. And with the or statements, this is one where you just split it up. So you're going to have u plus 2, and when you make that -4, because you've got the negative in there, you are going to have to flip it around to make it less than. And then we're going to do u plus 2 that one won't change, and it'll just be greater than 4. And again, when we graph it, it's just going to be an OR statement. Okay, so only one thing to do. Subtract 2 from both sides. For that one, we get u is less than or equal to -6. And we'll do the same thing on the right-hand side. We're still going to subtract 2 from both sides. Get u greater than or equal to 2. So again, if they ask you to solve it, that would be your answer to solve it. Now again, I don't think from the problems I'm looking at, they don't ask you to solve it. They just tell you to graph it. So you're really, that's your setup, that's your work to get to the point where you can graph it. And once you graph it, again, it should look like oars on a boat. So we've got 2 and -6. This one, wait, we're graphing it, not doing interval notation, sorry. I was thinking interval notation here. If you graph this one, it's a solid circle at -6. This one's headed to the left. This one's a solid circle at +2. Headed off to the right. Okay, and they are not asking for interval notation, they simply want the graph on these. Okay, and if there's any good news to these, there's no doing 2 graphs at one time and seeing what the answer is. For all these problems, when you start with absolute values, it's either OR statement, where it looks like it's the right and left end of the graph, or it's just everything in the middle. There's not any in between on this one. It's one of those 2 graphs, and there's really nothing else the answer is going to be for this part of it. Okay, so let's go with absolute value of w minus 8, and that's less than 2. Okay, so when you do this one, because it's less than, that means it's an and statement. So when you solve this one, you're going to sandwich this problem between +2 and -2. And then we're going to take this w minus 8 that's here, just put it right in the middle. Okay, and this, and again, it goes right back to the 9.1. That is, as long as you sandwich it between the 2 numbers, then you're going to work from the inside out. So you got this -8, you're going to do +8 to all 3 parts. So we've got 6 is less than w, which is less than 10. And for that one, that is your answer, because there was only that one step to do here. And when you graph it, we're going from 6 to 10. And again, as long as it's an and statement, it should be everything between 2 points, and then it's just everything sandwiched between those 2 points. And if you want to draw a bun on top, there you go. There's your sandwich. See, I can draw a sandwich. It's like a manwich meal, right? Okay, and everything else is just, oh, too far. Everything else is just some variation of those two problems. They may give you something where you have to do a little bit more work or a little less work to get the answers. But it's all just figuring out, okay, is it an and statement or is it an or statement, and just working through the numbers here. And from the parts of it I've seen, they don't get superly long, complicated. May have something like this where you've got t minus 4 plus 1 less than 6. Okay, the biggest thing is if you get one like this, it's like the other problems back in 9.1. You've got to get the absolute value by itself. So before you do anything at all, get rid of that 1. So you've got an absolute value of t minus 4 less than 5. And again, it's all about what the signs are. That's less than. That means it's an and statement, so we have to sandwich it between positive 5 and negative 5. Okay, and again from there, you're just going to work from the inside out. So you've got t minus 4, so you have to do plus 4. So I'll leave you with a negative 1 less than t, which is less than 9. Okay, and answer-wise, it's going to look the same as the last one. These are both just less than, it didn't have the bar underneath it, so they're both open circles. And you just need everything sandwiched from negative 1 to 9. Okay, and all they're going to do is they're just going to, depending on, and again, everybody's level is a little bit different, but all they're going to do is just give you problems where in the beginning of it, you know, if you get through the problems really quick, you're just going to have a little bit more stuff around this part of the inequality. But it is still just that exact same thing. You're just going to keep building and working through the problems. So let's give you one more here. Go greater than or equal to let's go with 7. Okay, the very first thing is, again, get rid of that negative 6. So add 3 to both sides. Sorry, add 6 to both sides. So you got 2x minus 3 greater than or equal to 13. That's greater. So again, that's greater. That's an or statement. So when we get finished, it's got to look like oars on a boat. You should have a gap in the middle, and the arrows pointed off to the left and the right. Okay, now when you solve it, and again, this one with the or statement, you actually have to solve it 2 different times. So we're going to do 2x minus 3, and when you make this a negative 13, you are going to have to flip that inequality sign. Make it go that way. And this one is going to stay the same. Because if you don't change this sign, you don't have to change this sign. When you change this sign from positive to negative, you also got to change this sign from greater to less than. So sign stays the same, sign stays the same. You change the sign, you got to change the sign. And even on the and statements, when we did it, technically we were changing the signs. We just wrote it so it kind of worked its way out there. Okay, for this one, I'm right up against the bottom of the page, so we're going to write kind of small. Add 3. We've got 2x is less than or equal to negative 10. So we divide both sides by 2. We get x is less than or equal to negative 5. And for the right-hand side, we'll do pretty much the same thing. We're going to add 3 to both sides. We've got 16. When you take 16 divided by 2, we've got x is greater than or equal to 8. Okay, we'll put the graph here so we don't have to put it on just a whole different page. Okay, and again, if it's an or statement, because it was greater, it's an or statement. When you get finished, it should be flipped out where you got a gap in the middle. So negative 5 is here, 8's here. We're going less than or equal to negative 5, so that's a solid circle. Headed that way. This one's greater than 8, so that's a solid circle at 8 headed that way.